back to the channel, everyone. Hope you're having a good day wherever you are. So this one is going to be a sort of a pseudo part 2 to my inverter video, which I'll leave a link down below. And I've just ended up with a few other bits and pieces of as an extension to that, and I figured I'd just do a video about it because why not? So the first thing is I've taken the old inverter apart, so I'll show you a couple of things in that and a couple of reasons as to why. And the other thing I also want to do is on the inverter I put on the wall over there, not the big one that's up here, is I want to add an earth leakage dropout on it. So I've got them, I've just got to fit them up. So I figured I might do that in this video while I'm at it. So the first thing I'll do is go through the additional sort of bit I've got to do on the inverter that I'll put on the wall over here. So you'll see the inverter's here, and the problem that I'm going to overcome is obviously I've got my fireplace down here. So obviously there's a risk of smoke and heat in general coming up into here. The other thing I've also got that I want to do is I've got this fan here that blows cooler air during the summer, obviously, because that's what it's, summer here at the moment. I've also got another fan just down in there that'll blow the air around the hot box here, so that'll push some air out there. But obviously as the heat rises off here during the winter, I don't want it interfering too much with this, but then it'd be nice if that heat came up and then got sucked into the fan, because the entrance to the fan is just there, and get some of that heat blown out here. So what I'm going to do is I've decided I'm going to use parts of the old inverter to create a barrier here, but also just to push up that heat up into here. So this is the inside of the old inverter that I pulled apart. So it's got a fairly decent sized heatsink to keep everything cool, which is good. And it's also got the lid, as you can see here, that is also aluminium as well, so it had some fairly good heat dissipation on it, so that's not too bad. I think it was just old, so it was just beyond its capability these days. So the other interesting thing is you can see the battery terminals here are joined together. I didn't know that, so I also joined them together here. I think obviously just so you could run 2 cables to it to make it draw more power if you needed it to. But then the cables going to the actual board weren't exactly the biggest things in the world, which is interesting. For this particular unit, there's 4 actual power supply creations, but 4 sort of, I guess, separate inverters. So that's why there's the 4 cables. So there's 1, 2, 3, 4, and then they were merged back up the other end into here. So these power wires for your active and your neutral, and obviously the earth as well, were all actually joined as well. So didn't matter which one of these you used, you got the same power out of both of them. But then they don't look exactly like big wires, so they didn't exactly fill me with a lot of confidence. But they were going to the same spot on either side of the board, so these were all sort of effectively paralleled up. So actually that wasn't too bad a design. I didn't mind that at all. So it's also got this display. So it used to show DC power, and also it said something about AC draw at the time. I don't know how it did that, because it's only got positive and negative and then 1 feed, so whether that feed is a data feed or not, I'm not sure. That's okay. I might pull that off and keep that. If I put some decent sized power wires onto these 2 sockets, they might actually be useful. And I might pull the fans off and then keep those wires and the terminals as spare parts, and then the rest of it can probably just go, because to sort of try and refurb this, I think it would be too much. There's quite a few fuses in there I'll pull out, because they're all automotive type fuses, so that's good. So that's the little history lesson on that one. So this is the base or the lid? This is the base. So what I'm planning on doing is, I haven't quite figured out how I'm going to do it yet, but this is either going to be a piece to go up the back behind the fan, or I might use this, the lid. So then I'll just have to cut a piece off it here just to trim it up so that it fits underneath the back of the fan, because the fan's got obviously the motor point on it as well. So I just need to cut these bits off, so then I've got this plate that I can then screw to the actual back of the fan. So that should be alright. And then I might just put this on a bit of an angle, so then it goes down to the bottom of the inverter, and then I'll just go straight down after that, just because that will then divert the heat sort of up here and push it into the back of the fan, which then can circulate that through the workshop when it's cold. But it'll also then protect the inverter from the heat that comes off the fireplace, and then also it will enable me just to make sure that none of the smoke that does filter out of the bottom of the top of the fireplace doesn't actually get into it as well, because otherwise it'll end up a bit crusty inside. So as an extension to those of you that saw the video from the other day, I talked about putting this control unit in, which I've now done. So basically what that enables me to do, instead of having to come down here and actually switch the inverter on and off through the button that's here, I can just do that through here, and you'll see that it'll turn on, and eventually the power will come up to 240, 230, and it tells me how much, what the voltage is in my batteries and whether the battery's full or not, the heat temperature in the inverter, and the obviously the power if I'm drawing any power out of the inverter at the time. So what I'll also now be doing is I'm just going to put a plug on here and have that coming up out the side, so that, because obviously with this being covered, it'll make it a little bit harder to get to, but also if I've then got all that covered up, it'll protect it, and just means I now need this sort of other bits to control it, which is okay. And then I might I'm thinking about putting a power point here that's just going to run off that with the trip on it, so it'll just be here that I can get to. From the measurements I've taken off this, it seems that the two power points that are on this, so you'll see that there's two, I don't know if you can see it or not. How about we try this? So you'll see there's two power points here. They don't seem to be connected together, so it's probably 2500 watt divided between the two power points, so that makes it a little bit less, but seems to be able to do some things okay. But that's alright, we'll deal with that if it becomes a problem later. Alright, so what I've decided, because if you look at the hole here for where the fan comes out, when you actually go underneath it, the width is about the same. So what I'm going to do is I'm going to definitely use this as the sort of the back plate for that underneath it. So what that's going to enable me to do is I'll just cut a piece off here. So then this piece here will become a back plate that'll sit, then I can screw it to the fan, because obviously the sides of the fan will then sort of sit here. And then what I'll do is that will sit on an angle like that. So then I'll just be able to have that sit there like that. And then what I'm going to do next after that, or before that, whichever way it goes, is I'm going to screw this piece of metal to the bottom piece of the wood that the inverter's mounted to, and then bend it up so that it ends up covering the majority of this part here. I'm going to make it probably that wide, so I'll cut it off here on this bit. So there will be a bit of entry hole here for a bit of smoke maybe, but I think I'll just deal with that because I don't have any other metal that I could use. I don't think, not that I can get hold of easily anyway. So just reusing the bits that I've got here, it won't be too bad if I just do that. So yeah, I'm just going to put a fold here so that rests up against that, which will protect all of this part here from getting smoke and stuff on it. And then with that other piece coming down here, that'll hopefully join up. And then, because I could even put that on a bit of an angle just to give that a bit more reach, because I only need this power plug to go into there, because then the cord will come out that way, and it'll just make it easier to divert, and then that'll also mean that this piece will have good ability to hook onto, get bolted to to the old cover that's there. So that's what we'll do. Then the next thing I'm going to do is figure out how I bend metal, because I don't have a metal bender. That's all right. Alright, so I said I was going to use this to hook up to the inverter because of the flat head on it, which is what I need. But then as I was looking for wire for the actual to go into that plug, I found this one, which is from an LG TV, I think. So it's still rated to 240 volt at 10 amp. So it does say it in there, and it's not like I'm going to be dragging anything more than that through this cable. So I'm going to use it. So what I'm going to do is obviously plug this into the inverter. Going to cut this end off, have it run through the RCD unit here, and then it'll go into just this plug socket that I'm going to put up on the on my little board with my with all my other bits and pieces. So then I can just plug directly into it. I was going to put a PowerPoint up there, but I generally only turn it on when I actually want it on. So having a switch to PowerPoint there is probably not relevant. So I'm going to just use that, and it'll be a little bit less troublesome for putting it together. It's got a base, so thankfully for this base, the two holes that are here and here line up on the solid bits of wood that I've got behind the switchboard that I've got up there. So it'll just make it easier to plug it in and screw it up and hold it properly, and then I can just punch a hole through here that'll go through everything so that I can just run the cable in from up the back of it. So that's what we'll do next. Alright, so I've just done a measurement by hand from where the inverter is to where I'm going to mount the RCD. I've got a little bit of DIN rail left over from another project. That was the vacuum cleaner remote control. I'll leave a link below for that one as well for anyone who's interested. So I know this isn't the ideal way of doing this, and I probably should use proper 240 volt cable for it. I mean, it is proper 240 volt cable, but just the actual what do you call it? The 2.5 mil 20 earth or 1.5 mil. But because it's only going to be running, and I can only plug that directly into the inverter. I can't actually hardwire the inverter, so unless I pull it apart, which I'm not quite prepared to do. I guess the other important thing to note is that I can never leave any of this plugged in and turned on overnight, so I'm always in here when it's on. So that sort of alleviates the sort of, I guess, the safety issue of it. So this one's got the neutral marking there for me. So obviously neutral's going to go in there at the top. And because I'm already using this cable, I'm just going to cut it up some more and use it for the feed from the LCD to the socket. Now we'll just wire these two in. Alright, I've got my three ends here that will go into here once I've actually screwed it up to the top. Alright, so I've just got this piece of leftover earth from something else, so I'm just going to hook that into here so it can go to this just as an extra safety part, and then I can hook it up to the rest of the earth. Alright, just got the plug here, plug it all together with. will go into there, and then when I screw it up, I'll make sure that the earth goes onto that, just to be extra sure for that piece. Alright, as you can see, that's just sitting on the other side of the faceplate. Sorry, my little switchboard, which is here. So there you can see the power 12-volt cigarette lighter socket that I've got that runs the other fan for the fireplace, and obviously now I've just got the RCD just tucked away in the corner there. I couldn't show you me actually putting it in because I could barely see what I was doing as well, and don't think you really need to see the back of my head for 5 minutes while I mumble it trying to put some screws in. But then on the other side of that, the earth is just tucked into the screw there, and it'll go to my earth on the building here. So now I'll just come back around the front here, and I'll start putting in the socket here. I can't get rid of this cable because that's what's keeping my camera alive. I can just run it on the battery, but it won't last as long. So yeah, the socket will go here. There's already a screw there. I think I've just got to add another one here, but you'll see that as I do it. So that gives you a nice picture of the RCD that's there, and the fact that the socket's going to go just here as I do it. So I'll just pop that screw out. Alright. It's going in. Alright, that's one screw. That was the existing one, now I'm just going to find another one. And the good thing for this one is there's a solid piece of wood there, so it'll just sit in there quite nicely. Now I'm just going to put a hole through the whole thing. Right, so now I've got that there ready to go. And now I just screw all those in, and that'll be done. They're in. There we go. Alright, let's make sure it's actually working. Okay, that's part one done.